Hello guys, welcome to this video lecture on pointer arithmetic. Now there are basically only two types of pointer arithmetic I can perform. The first one is I can either add integer to a pointer or I can subtract integer from a pointer. And the second one is I can either subtract two pointers. So let me first talk about pointer plus minus integer, the first one. So let us first take an example. If int a is equals to 20, let me assume that a is allocated a memory and let the address be 1008 and the value inside a is 20. Now let me create a pointer called as p, which is having the address of a. So now p is a pointer. P is having the address of a, which is 1008, and let the address of p itself be 2000. So this means p is pointing to a. Now what happens if I do p plus 1? P plus 1 is nothing but I am adding 1 to a pointer. So p is 1008 plus 1. Do not confuse that this will not be equals to 1009. This is wrong. 1008 plus 1 is actually the address of the next integer in the memory. So it would actually be 1008 plus 1. This is the offset into size of int. Size of int because my variable is of type int. This p is of type int is a pointer. So it will be actually 1008 plus 1 into, let me assume that size of integer is 4 bytes. So it will be 1008 plus 4 is 1008 plus 4 is equals to 1012. So if I do p plus 1, I actually get the address of the next integer, that is 1012. So if this is 1008, 2011 is reserved for a. So next integer would have the starting address as 1012. So I'll get the address 1012. Now if you look at this actually does not make any sense because 1012 is not allocated for any of the variables in my program. So 1012 may be allocated to some other variables, which is like this actually is not a legal address. Although this will not give you any error, but this is not legal. Similarly, I can also subtract an integer from a pointer. So if I do p minus 1, what I get actually is 1008 minus 1, which is again not equals to 1007. I actually need to do, I'll get the address of the previous integer variable. So this one, the previous integer location, right? So the address for this one would be 1004. So how do I get this 1004? I'll do 1008 minus 1 into size of integer is 4 bytes. So 1008 minus 4 is 1004. So this is how the first one is done. Although this kind of increment and decrementing a pointer is not making any sense here because we are not getting any legal addresses. This will make sense. Both of these arithmetic will make sense whenever we are talking about arrays. I'll talk about this after some time. Now let us look at the next kind of arithmetic, that is pointer minus pointer. Okay, so I can very well subtract two pointers given that both are of same types. Okay, so if both the pointers are of same type, then I can perform this, otherwise I cannot. So the requirement for this is both of them should be pointer of same type. So let us take an example. If I have this int a is equals to 20, okay, and b is equals to 30, let me have two integer variables, let me create two integer pointers pa and pb, and let pa have the address of a and let pb have the address of b, and let pictorially a look something like this, let b be something like this, let the address of a be 1000 address of B, let it be maybe 1012. So this is randomly allocated address by the compiler. Okay, and PA is having the address of A, so it will have 1000. So PA is pointing to A. PB is a pointer which is having the address of B, that is 1012. So PB is pointing to B. Let the address of PA be maybe 2000 and 2016, for example. Alright, now in this example, if I do PA minus PB, what do I get is this is a valid, valid operation here, because PA and PB are pointer of same type of integer. Both of them are integer pointers. So PA minus PB is a valid expression. So if I write PA minus PB, what do I get is 1000 minus 1012. Okay, so you may assume that the answer should be 1000 minus 1012 is minus 12, but you will not get minus 12. The answer actually is it will be scaled by the size of integer, scaled down by the size of integer, because it will be minus 12 divided by 4, because size of integer is 4 bytes, so it will be minus 3. So this means they are 3 elements away from each other. Okay, similarly PB minus PA is also a valid statement here. If I write PB minus PA, I'll give 1012 minus 1000, which is 12 divided by 4, so I get the answer as 3. That means there are 3, there are 3 integer element away from each other. So it is 1000. The next one, the next integer will have the starting address is 1004. The next one will have 1008, and this is having 1012. So the difference is 3. Okay, there are 3 elements away from each other. So this is about pointer arithmetic. But I can't perform pointer arithmetic if PA and PB are of different type. Okay, so suppose I have a character. So suppose in this particular sequence I have a character maybe C. Okay, and I have got a character pointer called as PC, which is having the address of C. So now I can't perform PA minus PC. This is not valid, because PA is of type integer pointer, this is of type character pointer, so this kind of arithmetic is not permitted in C. You observe here, subtracting 2 pointers like this is actually not making any sense. So again, subtracting 2 pointers should only make sense whenever we are talking with respect to arrays. So now let us understand both of these pointer arithmetic with respect to arrays. Now let us understand pointer arithmetic by taking this array A with 5 elements, and the memory arrangement of these 5 elements is shown here. I am assuming that the base address of this array is 1000 and the size of integer is 4 bytes. Now if I do this, if I create an integer pointer P, okay, and if I make it point to the element at index 2, so I'll do A2. So now P is a pointer which is having the address of the element at index 2, that is 1008. So P is having 1008. So P is pointing to this particular element. Okay, let me also assume one more pointer called as Q, which is actually pointing to the first element. Okay, so I can very well write star Q equals to A, or I can write ampersand A0. Both are same thing. Okay, I can either write directly A because A is the base address, so Q is a pointer which will have the base address of the array, that is 1000. So Q is pointing to the first element. Alright, now if I perform P plus 1, what do I get is I get I'm actually pointing to the next integer after P. So I should actually be pointing to this value minus 3. So P plus 1 should technically be 1012. So if P is 1008, 1008 plus 1 is nothing but actually 1 into size of int 4, so it will be 1012. Okay, so this is nothing but P plus 1. P plus 1 is not 3, but P plus 1 is actually 1012. Okay, this is 1012. Now I can also do this. I can do p minus 2. If I do p minus 2, what do I get is p minus 2 is 1008 minus 2 into 4 is 1008 minus 8, it's nothing but 1000. So I get the base address. So p minus 2 is nothing but it will point to the first element, so it will be 1000. Alright, now so this is how pointer arithmetic works here. So it makes sense here, because we know that in an array the elements are consecutively arranged. So if I do p plus 1, I actually am advancing my pointer to the next element in the array. So if I do p minus 3, I'm moving left by 3 elements. So this is this actually makes sense in pointer. Okay, now I can also do, if I do here, so q is 1000 and p is 1008. So if I do p minus q, it's a valid statement because p is a pointer, q is a pointer. I can subtract them, okay, and both of them are of same type, so it is a valid statement. So p minus q would be 1000, 8 is p, q is 1000, and then I need to divide this by the size of int, which is 4. So it will be 1008 minus 1000 is 8 by 4, this is 2. So it's as good as writing, this index is 2 and this index is 0. It's as good as writing 2 minus 0, that is j minus I. So if this is index j and this is index I, j minus I is equivalent to p minus q in this case. When using pointer arithmetic, be careful with it, because you may very well be pointing to illegal memory location. So while using pointer arithmetic, be careful and make sure you are pointing to a legal address. That's all for today's video. Thank you.